Wait, look at this. Can you explain this simple diagram? This is motion under gravity. Welcome to Knowledge Base. In this video, I am going to explain what this diagram is all about, as it is a representation of motion under gravity, and I will solve a simple problem to demonstrate how this sort of diagram works. If you are watching this video, please stay tuned and watch till the end so that you can understand every bit of it and you wouldn't want to miss any part of it. This diagram is motion under gravity. It is a case where an object is thrown up, it gets to a maximum height, and it falls back to the ground. In this kind of motion, there are two cases: the upward motion, case 1, and the downward motion, case 2. Let us look at these two cases properly. For case 1, we'll be representing it with u1, v1, while the downward case, which is the downward motion, which is case 2, we shall represent with u2 and v2. So let's write on. When you throw an object up, you apply a force to throw that object, and so the object moves off at a speed. That initial speed with which the object moves upward is what we call u1, initial speed. It could be anything. It could be 10, it could be 20, it could be 40, 50, depending on how much force with which you threw the object upward. So an object thrown upward moves off with an initial speed. And because the object is moving up, it moves up against gravitational pull, because we all know that gravitational force is the force that pulls objects downward. But now you've thrown an object upward and it is moving up against gravity. Hence, the acceleration due to gravity is negative. As the object is going up, you agree with me that it keeps slowing down and slowing down until it gets to a point where we call the maximum height, where the object gets to and it stops. At that point, the upward motion has ended. So the final speed of your upward motion, v1, is what? 0, because the ball will stop at the maximum height. Now let's consider the second motion, which is the downward motion. The downward motion is now going to start from that maximum height. And you will agree with me that the speed of the downward motion, the initial speed, is equally 0 because it's just about to fall down from a maximum height. So u2 for case 2 is 0. As the object is falling down, you agree with me that the acceleration due to gravity becomes positive. Why? Because it is falling in the direction of gravitational pull. So it is a positive sign as far as gravity is concerned. And as it is falling down, what happens? It is gaining speed, and it will eventually hit the ground at a speed which becomes the final speed of case 2, v2. Experiments have shown that this final speed, v2, is always equal to the initial speed, u1, with which the object was thrown up. So final speed on the ground equals to initial speed with which the object was thrown up. Now, this is an explanation of this simple diagram. Let us look at an example to demonstrate what has happened in this diagram. A cricket ball is thrown vertically upwards with an initial velocity of 40 meters per second. It means for this motion, u1, or the initial velocity with which the object is thrown, is 40. Let's put it down. U equals to 40 meters per second. The first question, 1, says, find its velocity after 3 seconds. 1, find the final velocity. We don't know it. After what time? After 3 seconds. This is the formula we are to use. V equals to U minus GT. This is one of the equations of motion. Why are we using minus instead of plus? Because we are looking at the upward motion. The ball was thrown vertically upwards. So upward we have minus G. So this is minus. We are looking for V. We know U as 40 and we know T as 3. So if we put the values, we have that V equals to 40 minus the general value for acceleration due to gravity is approximately 10. So we have 10 times 3. So this becomes v equals to 40 minus 30. And so the velocity after 3 seconds is 10 meters per second on this particular case. So we are done with number 1. Let's look at number 2. Number 2 says, what is the maximum height it attained when you threw it up? So when the ball was thrown up, we want to calculate the maximum height it attained. We recall the formula. V square equals to U square minus 2GH. H here is representing the height we are looking for. This is another equation of motion. In case you're surprised where these equations are coming from, look back on one of our previous videos. We treated various equations of motion and we highlighted what each of them stands for. So you might want to go back to that video, understand where the equations are coming from, and come back to this video. But for now, keep watching this video. So we have that V square equals to U square minus 2GH. The final velocity at maximum height from our diagram, we say the final velocity is always equal to 0 because the object will stop momentarily. So we have that 0 equals to the initial velocity still remains 40 because the object is thrown up at 40. So we have 40 squared minus 2 times 10h. 10 because g is 10, minus because it is an upward motion. So if we solve this further, 2 times 10 is 20 minus 20h. If it crosses the equation sign, becomes 20h equals to 40 squared. 20h is equals to 1600. 40 squared 1600. So we obtain h by dividing both sides by 20. So that h is equals to 1600 divided by 20, and that is 80 meters. So the maximum height attained by the ball is 80 meters. We are equally told to find the time taken to reach that height. So what is the time it takes to reach this maximum height? Again, we recall this formula because we have t here, so that we can make t subject to formula. Time to reach maximum height, v equals to u minus gt. We know that at maximum height, v is 0, so minus gt crosses equation sign to become gt equals to u. If v crosses, becomes minus v. Again, we know that v is 0, g is 10, so we have 10 times t. 10t equals to u is 40 minus 0. If we do this, we divide both sides by 10 because 10t is equals to 40, so that t is equals to 40 all over 10, and that is equal to 4 seconds. So it will take 4 seconds for the object thrown up to get to the maximum height at 80 meters. And lastly, we have to find the total time taken for the ball to return to the ground. So what is the time taken for you to throw it up and for the ball to come back to the ground? The total time taken is simply equals to 2 times the time to reach the maximum height. So the time it took the ball to leave the ground to this maximum height is the same time it will take it to fall back to the ground. So we simply multiply the time we've obtained earlier by 2, so that the total time is equals to 2 times 4. 4 from our previous calculation of number 2, time to reach the maximum height, so that the total time is equals to 8 seconds. So this is the answer to number 3. You can see that the question is very simple and very interesting. Now try this. A stone is thrown vertically upwards with a velocity of 30 meters per second. What is the maximum height it reached? Please put your answer in the comment section, and thank you very much for watching this video. Please share this video to others so that they can learn what you're learning on this page, and that way you keep encouraging us to make interesting content. Once again, thank you for watching.